For tonight, we're going to be looking at this project, which for those of you receiving the newsletter, you should have received notice of this already. It's a simple project, but there's some pretty cool little techniques in there with VCarve that we could go over. And also, if you're looking for any of the past projects, they're all located out at the Next Wave website. And that's where you can download the PDF and the VCarve file as well. So with that, let's hop over to VCarve. Well, tonight's project is this small drill driver setup. And like I was saying, it uses a few techniques with the drawing, which have some little tips in it that we're going to go over. So I'm going to hop right into this and go through the design of this, which once you have the layout like I have here, it's pretty straightforward, and this will go fairly quickly. But I messed around with it when I was designing to try and get the proportions and the spacing, and gave it a little thought for, space for finger room and the length of the bits. So there's always a little more upfront design work when you're working with it. But VCarve is a nice program to do some of that practicing in for the layout. So let's get up close here. So the first part of the setup here is to go in and get a rectangle. And inside this rectangle tool, you also can draw radiuses. So the basic size of this oval here, or this racetrack shape, is 6 inches wide by 10 tall. But if we want to have that nice radius end, of course, half of 6 would be 3. So we can check this radius external, type in 3. I also have already programmed in here the 0, 0, because that'll be the middle point, which is the center of our material. So this places it exactly where we need it. And it's that straightforward. Now, if I close out of that and I have this design, if I want to resize this, a pretty common place to go is go inside the object size. And of course, I can link that and resize it. And that does resize it. But the other option is to actually select it and go back inside the Draw Rectangle tool. And here, since it's active, if I give this a different width and hit apply, it'll go out and actually just automatically change the width, but it'll keep those radiuses. Also, if I wanted a smaller radius, I could change that radius and modify it like that. So that way I don't have to bother with the fillet tool later on. I can just go into this shape and do all the design work right within that one Draw Rectangle window. So it's a handy little tool that, even though you've drawn the product once or the design once, you can simply go back in and reactivate it. And next we'll jump over to, we're going to use the offset tool for these offset lines. And again, here, this was one I came up with the spacing. It looks good, and it worked out well from a, living room for my fingers and space for the bits and all that. And this is the offset tool here in the lower left. And we can see that our first offset is 1 inch. And one of the settings here that I like to use is called Select New. If I don't check that and I create my offset, notice this, it'll create the offset, but the original remains selected. And if I'm doing multiple offsets, I click Select New, and it automatically selects the new, and it just saves me a couple of mouse clicks. I can type in the new spacing, click offset again, and now I have the two ovals, and they're very proportional to the original size. So that select new is handy when you're doing multiple offsets. And now for doing the circles, I determined that this 0.31 works out pretty well for drill driver bits. It gives enough space, but it doesn't make it too sloppy in there for the bit for storage purposes. So we'll use that diameter tonight. I'm simply going to go in here and I can type in the dimension up here and then just go over and I'm going to click right here in the middle for now. That'll just place it right there in the middle. And then a quick way to create this array is just using the array tool. And I'm going to have 6 holes. And now the spacing is called the offset spacing, which basically is middle to middle or center to center. The gap represents the distance between them, but I determined that I want a 0.8 offset between those holes, and I want 6 rows, which are the horizontal direction, and then 1 column, which is the vertical direction. And I'm not going to group those right now, so I'll click on copy. And while they're still active, a quick way to align those is use this center vertical tool, and that'll just pop them all down to the middle location. Or if for some reason, if I had created these off to the side, I could do the center location to pop them back there as well. Now, for doing the array around the sides, like I said, I was looking for a spacing that was a little bit wider than my middle ones, but looked like it would work out well. So I'm going to select just one of those existing circles. And for this application, I'm going to use something called copy along vectors. If you haven't used this, it's a pretty interesting tool because it'll follow whatever vector you have drawn. So whatever shape that is. So in this case, I have the circle selected. I'm going to hold the shift key down and select that first oval. And it shows here that I need 16 holes, but I'm just going to start typing in. Let's go, like I said, when I was working with this, I just tried some different sizes to see how the spacing, because it shows that it's going to set it up and it's going to try and do an even spacing between all of them. So that places it like that. And you can see on the final design, I've got one here at the end and one at the top. And obviously it's not balanced right there with 10 holes. So let's go up to 11 holes, see what it looks like. And obviously that's an odd number. So I'm pretty obvious that an odd number isn't going to work. So let's try 12. Okay, that layout isn't too bad because, it's symmetrical. That's what I was looking for. I was looking for a nice symmetrical, but I'm going to keep going up to my, go up another 2. It moves it around again, and I'll hit 16. And that lands me where I was with the final design. I've got a hole here at the end is which I wanted. Just from a kind of a visual standpoint, I wanted a lineup of holes through the middle. I've got a nice spacing, which is slightly bigger than what these are. This is maybe about 1 inch apart. And now before leaving the tool, I can hold the shift key down, deselect that one, hold it down again, and select the new oval. When you're working with a tool, using the shift key to select and deselect, you can save some of the mouse clicks by kind of working systematically at it. Now, in this case, I start out just putting in the same number of holes, and, that kind of works. I don't have one at the end here, but the other thing I was looking for is trying to kind of get an offset between these front holes so my fingers could go between them. So I'm going to go up another hole, and obviously that doesn't work either, but 18 is where I finished at. But notice something, that still doesn't work. And so this brings into the topic of where is the V-carve looking at to lay this out? And if you're not familiar with this, if I click on this oval, every closed shape, a circle, a rectangle, a square, a triangle, whatever, every shape has a starting point, even if it's a closed starting point. You can think of it like where it's welded together, the two ends. And the way you can find that start point is by going into Node Edit and looking for the green dot. That green dot is what's called the start point. And so these circles are being laid out based on where that green dot is. Well, it's obviously the spacing's not working out. So then the question came up, well, what about this one? Well, this green dot is in the same location. And I guess you can say we got lucky on that one because the spacing still worked out at the end and at the side like that. But the spacing is not working for this one. And so to change that location, I could simply go over one of the dots or one of the nodes right there, right click and say make start point, or I can click the P key. And notice now how it moved the start node to that location, the start point. Now let's see if I can hit Control Z and undo my circles. Now it actually moved my start point. Let's go again. There we go. And I'll go back and redo that start point. Now when I do the 18, whoops, it closed out. Let's go back to it. I've got to select my circle and that oval. Try that. Okay, something's going on here. Let's see, what am I missing? Oh, I may have selected them in the wrong order. Let's try this. There we go. So now I have all of those. So let's zoom out here a minute and see what I have out here. Yep, I don't have any extra vectors. So now you can see those light up nicely all the way along there. So the start point, as I was saying, sometimes you're doing layout, if it is not ending up symmetrical or in the order for the array that you were hoping for, consider where the start point is and simply go into Node Edit. Like in our original one, if I go into Node Edit, you can see here the start point is over here. When we offset it, the start point moved up to this upper right corner. Not quite sure why it did that, but that's just the way it worked. And you do control that location. Now, let's take a little side trip here on this offset tool. I mentioned how I'm going to take and take that zigzag line. I am going to go into Node Edit, go over that node right there, and I'm going to click on Smooth Point, and that'll turn that point into a Bezier node. And then I can do the same here. So now I have this kind of zigzag line. Then I'm going to take a star, and actually let's do a four-pointed star. It'll illustrate things a little better. And that looks like a good size. Now, if I want to take a shape like this and lay it out on the zigzag line, again, I would highlight that, select the line, go to the copy array along the vectors. Now, some of these other options that we have here is if I do 18 copies, it'll do much like I did on this circle. It'll lay them out on there. So let's just do that. So there's the 18 copies laid out. Let me back up. I'm going to make that a smaller number. Try 10. And even a little smaller. Let's go 8. Now, for this basic setup, it's doing 8. And notice how it's starting at the bottom, in the middle of the star, and the top, the middle of the star. And then it's evenly spacing everything between it. So we're not controlling the spacing at all. It's just dividing it up equally by that number of stars. While we have that, and also notice here how the stars are all still oriented, north and south, east and west, all the way down. They're still located vertically. If you place aligned objects to the curve, it will rotate that to align it with the curve. So let's take a look at that. So there you can see how it follows the curve. So if that's the kind of creative design you're after, that's an option available as well. And of course, the other two options here, you can put it on a new layer or you can reverse the direction. Now, reversing the direction for us, you probably won't see much of a difference as opposed to the other way. But this reverse direction does come into apply if we start going with this distance between copies. So if we want exactly 1 inch between copies and we take off force the even spacing, it's going to start at the start point up here, which is that black node, and it's going to do 1 inch. And there may be some remnant at the end of this design left over. So let's give that a try. And let's see, we've got 1 inch spacing. Let's do that. Let's increase that to 2 inches. And let's go a little odd amount. There we go. That's what I wanted to illustrate. So the spacing between those is 2.5 inches, but notice that we have a tail left over here. And that's because it's doing the 2.5 inches. It's not controlling the quantity of copies. It's just doing the spacing and stopping. And this is where reverse direction comes into play, because as opposed to starting at the start point, if I click reverse direction, notice how now it copies it from the bottom up. So reverse direction primarily applies to when you're doing distance between copies. Now you also have force even spacing. And in this case, what it's going to do, it's going to fill the line, but it's going to try and get as close to 2.5 inches as possible, but it actually is going to force the spacing. So let's try that. So there you can see now it's similar to what we had earlier where we had the quantity and we went from end to head. But in this case, again, it's trying to do 2.5 inches and then it's just averaging it out close. So it's a fun tool when you're doing layouts like this, and for game boards, projects like this, other types of tool storage, it's a handy way to lay out things like this. So with that, go back to our design here. So we have everything laid out, pretty much everything that we need for our vectors. So at this point then, we can hop over to our tool paths, talk a little bit about those. So I have those set up already. And part of what I want to look at tonight, we're going to use, this is called the Ovals V Groove. Now, when I click on this, this is actually the 2D profile toolpath. Sometimes I find when people are starting out, they sometimes get confused between the 2D path and the Vbit V-carving path. The 2D profile path follows a vector. So it follows around on a vector. In this case, we have these two vectors, and you control the cut depth. So in this case, it's going to be 0.05 deep. And I'm going to go on the line. I'm using a 90-degree bit on the line. And the only thing I'm adding is a little bit of a ramp on this. So if I preview that, let's split that so we see both of those. So the difference between this and, say, a V-carving tool path is you can see it more often if you have, let's take, and I'm just going to draw a rectangle up here and use square corners on that. Now, if I apply this toolpath I just created for this V carving or this V groove to that rectangle and preview it, the first thing you'll notice that's somewhat different from V carving, it'll tend to have round corners. Now, there are some things you can do in there to control that. But the difference between this and V carving, if I were to do a V carving toolpath on this, V carving cuts inside the opening. So it would do this kind of number to it. If you wanted to create you'd have to create an offset, go outward, let's go at 1/8 of an inch. You'd have to create an offset on this if you wanted to do V carving with this. So the main difference between the profile toolpath and the 2D profile toolpath and the V carve is that the profile toolpath will cut on the line or right next to it, where the V carving requires 2 lines to cut between, called a closed object. So profile toolpath, which I'm using here, it is very common to use an end mill bit or a straight bit with this, but you could use any bit with the 2D profile toolpath. You could use a Vbit. You could do like a form cutting bit, if like a Roman OG, if you want to go around your project. That'd be another one that you could set up, and you just have to deal with the offsets and what the diameter of that Roman OG is to get the correct results. So let's go back and select our correct lines on this. And just to show you again, the final design on this is determined by the depth. And with a 90-degree bit, the width at the top of that cut is going to be twice the depth. So this is it's 1/10 of an inch wide at the top. If I go 1/8 of an inch deep on this, you'll notice that, select our lines. You notice how now it simply goes deeper. So V-carve automatically controls the depth based on the width of the line and based on the flat depth. With profiles, you control that with the V-carving bit. So we'll reset that. And then next up, I've got the chamfer. Now, sometimes you can cut the chamfer after you do the cutout profile, but I have found that it works just fine to cut it out in combination with this with the V-grooving one, since I'm using the same bit, and that way I don't have to do a bit change. Plus the cutout is going to cut down, and I've got tabs, so that I usually like to do the cutout last. Try to think, oh, that one I don't need. So I usually save the cutout till the end. There are some situations you'll find when you're doing a project that just if you're trying to save bit changes, you can go back and do the cutout right away. But in those cases, then usually what I recommend is add some generous tabs so the piece doesn't break loose, because that's where the problem comes in if the part breaks loose. Anyway, in this case, the chamfering toolpath set up. If you've not used this much, it's, let me check a couple here. There we go. The first thing to understand is that if it's a 90-degree bit, you could do a width and it'll automatically set the cutting depth, or if you change the cutting depth, it'll automatically change the width. And then the overcut, what that does is that brings the point out away from here a little bit. It doesn't cut any deeper, but it does, well, it doesn't change the angle, or it doesn't change any of this width or cutting depth, but it brings the tip a little beyond the edge there, and it usually leaves a little cleaner cut. Sometimes you can get a little fingernail cut along the edge of your board, and so that's what the overcut helps to remove. In deciding this, if you have not used this much, I recommend you go and play with a little bit. But inside, think of this red line, that's your vector. And So in this case, we want that chamfer to be inside that line. So that means it's inside. Also from that line, we want it to go up. So that's why we have sloped up. And this is going to be the most common setup. If you're chamfering around the outside of an object, it's going to be inside the line and sloped up. But if if we had cut out the inside of this, it would still be the same. If we were chamfering, if we cut out the inside of this, you would still end up wanting to see here, the chamfer is on the wrong side. So in this case, we're going to go to the outside, but we're still going to slope up. So the best way to do this is go ahead and set it up, preview it, then look inside your preview to make sure it looks correct. And let's calculate that. And then one other way to verify that this is set up correctly, here if we preview it, is when you go in, you may notice that we have this flat side. That's the waste side. So if you're getting this little flat profile, depending on which bit you're using, but if you're getting this little flat profile on your project, then you need to go back in there and change it up a bit. The other thing to look at is go inside your 2D view and look at the 2D preview. And you notice we've got a little wider blue on this side. That's because the middle of the router bit, let's turn these off. The middle of the router bit is passing like that. Remember that 0.03 offset we had? So the middle of the router bit is passing a little bit outside of that line, and that way the overall width of the bit is favoring the outside of your project. So that's the other clue that you can look for to make sure you're carving on the correct side of your line. Now in the hole setup on this, turn on my holes in this picture. Vectric in the last couple of versions have added this vector editing within the 3D view. So you can actually do your selection and you can do some layout in here. This did not appear until the last couple of versions, so it's really quite handy. So in a situation like this, I have two different depths of holes. If we go back and look at my project here, these front holes here, I decided, I want these for just the bits themselves or short bits, and then the rest back here for drivers and longer bits. So these holes are a little shorter. Probably could have made them all the same length, but then it tends to fall down to that shoulder, making them a little harder to get out. So I thought I'm going to take and just mix this up a little bit with the hole depth. So for the 1/4-inch depth holes, I'm going to take and select those holes and those, and then I'm going to group those to just make it simple. And then I'm going to go in and put the selection rectangle around everything else and deselect the ovals and hit the G key for group. So I have my two groups. So now I'm using a 1/4-inch end mill. These holes are a little over 1/4 inch, so that works out well. I'm going to the inside. Now notice how my tool end mill says slow on this. I have set up, see if I have it in my selection. I've set up a selection of end mills. So I've got a 1/4 inch slow, and you see that's a 30 inch per minute feed rate and plunge rate. That's what I use for cutting holes like this. I've got a medium speed for, if I'm cutting hardwoods or aggressively, and then a fast speed if I'm doing just some simple profiling that I can move along a lot faster. So I've just added that information to those tool paths. You do that by going in to this icon here and just typing it at the end. And so notice how you get your preview right here. And then if I type in fast, and then once you type it in, you click OK, and then that new name shows up there, and you can edit that. but we're going to use the slow one tonight. I'll click on that. And let's go down and calculate, click my circles, preview those. Now these little V lines are mostly just decorative, but I just thought to give it a little design, I added those in. And then we'll go back to our deeper holes. And the advantage of having a lot of these vectors grouped is I need to click, I just can click on one group and or one vector, and I select all of them at the same time. So I'm using the same bit here. I've set my cut depth. All the rest of the settings here are the same. And I'm going to calculate this out and preview it. And then the last one is the cutout, which is, we'll use the vector that's, oh, let me deselect that. Oh, here we go. I use a profile vector that we had set up for that large racetrack oval. Now this project's cut out of 1-inch material. It makes a nice, stout, sturdy stand for drill bits. It can work in 3/4 inch material also. You just need to make sure and go in and change this to 3/4 of an inch. Notice here now I have this set at the fast speed, so it's going to cut that out fairly rapidly. My path depth, I'm cutting about 1/10 of an inch, 18,200 inches a minute. Now on my HD5, this cuts fine. But if you have an HD6, you may find, because the HD6 is so much faster, it's almost twice as fast as the HD5, you may find that you need to tune this back to maybe 100 inches or 120 inches a minute on your HD6. What's happening on the HD5 has a much more aggressive governor. You know, if you think of a motor having a governor on it, a control in the control box. And so even though I have this set at 200 inches a minute, my HD5 is probably actually maxing out at about 120 inches a minute. And I've seen some cutting on the HD6, and I've ran a couple of tests, and it's true. It runs twice as fast as the HD5. So just be aware that depending which tool you have, those of you with the HD6, you're getting some excellent performance out of that. Calculate that out, and I did add some tabs to that, or I didn't. Let's go back. I thought I had them. Let's go back and add those. So let's look at the tabs here. Click on tabs, and then I need to edit those. So I'm going to use a 1/2 inch length, a 1/10 of an inch tall, and 3D tab. Depending on what wood you use, if you're using something like pine that tends to split easily, you might want to increase that, double up the length, or go thicker on it so it's more stout. The other thing I found, I'm going to add these in. So let's add tabs. Now it automatically added those tabs. I'm going to click on it and delete it. And I'm going to put them up here in the corners like this. I have 4 tabs. And let's close out of that. I'm going to make this a little bit longer. There we go. And reset, and let's preview all toolpaths. Now, where you place your tabs will depend a little bit on your project. I tend to like to place them usually on the end grade because it's stronger. The side grade can crack unless the tab is sufficiently thick. There's pros and cons both ways. If you place it on the side grade, you may want to make it a little thicker and a little more stout, because I have had projects on the side grade that'll actually crack out while it's cutting if it's too, if it's not thick enough. The thing about the side grade, it's very easy to clean that up with a, whether it's with a chisel or with a knife or a hand planer. On the ends, you need to probably sand that. But the end grain, because it doesn't have the short grade, it tends to be stouter and stronger. You don't need as large a tab of the end grade usually. The only thing you do have to be careful on both of them, really, but even especially the end grain, is if you put one right up here at the tip, and if you're not careful when you're removing it, I mean, most people, you should, use like a bandsaw or some sort of handsaw to cut that out. But every so often I've seen people, they try and make them thin enough so they can pop them out. And sometimes that tab will break out into your project. So you want to be careful when you remove those. So that's why I usually recommend sawing those with like a little Japanese saw or on the bandsaw. So that's that project for tonight. I knew we'd go fairly quick tonight, so we've got some extra time here. If anybody has any comments or questions about this project or other things in VCarve, we have some time we can look at that.
Yeah, Randy, it's Keith. Along with that same line, what should we use in the time calculator for? I use the inches per minute in the time calculator, the rapid rate.
Oh, good question right here.
Yeah, and that seems to have worked out relative. I mean, nothing's accurate because there's, if every cut you make is a 1/4 inch long, the machine's never going to get up to the feed rate anyway. I mean, there's an acceleration effect there, but I use a rapid rate. Well, I use a rapid rate of 200. The HD6.
That's the correct number to put in there.
Rapid rate. Also,
what's that?
For the 6 also, for the HD6 also?
I'm going to have to check on that. Because I think their rapid rate is closer to 400 on that machine. So you could probably up it. Rapid rate, what the rapid rate represents, just for everybody's information, these red lines, the red lines are where the router bit is traveling in the air above the material. So when it goes up in these areas, that's where it's traveling at its maximum rate, rapid rate. And obviously, Vectric has no idea what your tool is capable of. And even DexWave has tools that run at different rapid rates. So the maximum rate on the HD5 is 200, although I'm beginning to wonder if it even reaches 200. The HD6 is going to be way more capable. But I think if you tuned in, there's this number here in some ways almost has more effect. In fact, let's just look at this for a minute. Let's just play with these numbers. I'm going to kind of explain to you how to use this calculator. It's really an estimator. If I were to change this, so this top number here is 49 seconds, okay? If I cut that in half, I went from 49 seconds to 51 seconds. So because I have a slower rapid rate, it did increase my overall speed of my time. If I go to 400, I drop it by 1 second. So notice a rapid rate doesn't have a large effect on that number. So let's go back to 200. But my scale factor, if I drop that in half, notice how I cut my time in half. And if I doubled my scale from 3 to 6, I doubled my time. So scale factor is the one that really has a lot of effect. So I tend to leave, at least on the HD5. On the HD6, again, if you left that at 200, you're going to be within a second or two probably, or a few seconds of your overall cutting. But the big one that really has the effect is the scale factor. Now, there's kind of 3 general settings I look at scale factor. This is very relative, but when I'm doing cutting like this board right here, a scale factor of 1 to 1.5 is probably accurate. So let's look at 1. So at scale factor of 1, I'm just trying to think when I cut these, how these cut. Like I said, 1 to 1.5 on this is probably going to get you in the ballpark. What you do is you cut this project, watch what your actual times are when you run it. Either the overall total time is probably the easiest thing, or if you're running these individually, Then when you finish cutting them, see what the pendant says for runtime for the V carving bits and for the straight bits, add them together and see what your overall time is. And then adjust your scale factor to match that. And then the next time you do a similar project that involves mostly simple V carving, simple profiling, use a scale factor of 1 to 1.5. Now, if you start getting more complex V carving, you may find that you're going to be in the neighborhood of more like 2, plus or minus 0.5 maybe. And when you get into 3D carving, you're going to be closer to 3 times on the scale factor because there's so much more movement going on with 3D carving. So it's not consistent with every type of car or every type of bit. So that's why it's a pretty general estimator. But like I said, if I'm doing one like this, if I tune it into 1.5, it says the overall cutting time is going to be 15 minutes. I'm going to probably go to the shop and say, okay, I'm going to be plus or minus 5 minutes on this one. Where it really comes into play, and you can, of course, the scale factor really has a difference. If you're in a 3 or 4 hour cut, well, cutting that time in half or doubling that time is a big deal. So run a few 3D carving tests, see how your setup runs, and then that'll help you tune in on what scale factor you use for estimating later on.
Okay, that sounds good. Yeah, because it does vary. I always print the worksheets off, and I do record again, because the time, of course, shows up on each cutter.
Yeah.
And I record it and I look at it, and it's one time it's dead on, and the next time I do it in 50% less, and the next cut is 50% more, and it's kind of like, okay. And it's not like I'm using this to charge or anything like that. I'm just using it because I just want to know when I go to the shop, is this if I'm doing a 3D, is this a 6-hour run that I don't want to start at 4 o'clock in the afternoon? It's more, I use it more like that than anything else.
No, that's an excellent application for it. And if you are, when you're up against a long cut and you have a time frame, that's why it's worth keeping track and doing a few tests and kind of make a chart or a log that, like I said, if you kind of get a broad or a range in there for a particular type of carving, and then use those numbers later on. The other thing to realize on this, right now I have all these bits selected, but if I deselect these, make them not visible, notice how they're disappearing up above. So I could get the time for just one bit if I want it by checking the checkbox in front of it. So if I just want to see how long the V carves or the V bit's going to take, I could just do those two like that.
So that's where if you were doing if you figured out a 3D carve was a scale factor of 3, you could select just your 3D carve and then change that scale factor to 3.
Right. Yep. So let's say I thought, well, my V carve always, let's say I use a 2 for my V carving. Well, that's going to take 6 minutes. And then I go down here to my straight bit. And for that one, it's going to take, a scale factor of 1, and I'm going to use 7 minutes on that one. Then 6 and 7 together, is that's 13. Well, I can't get 13 doing it this way. I'm either 20 or I'm 10. So yeah, that's another way to more accurately determine your overall time.
Randy, just talking about surfacing spoil boards. Do you use raster? What do you use?
So I use the offset. So let's go in here, the pocket toolpath here. I use the offset that you can see right here. The reason for that, now you could use either one, but the reason I like raster, especially the first time I do it, is because it tells me I get ridges on the front and I get ridges on the side if there are going to be any. So I can read it in both directions that way.
Okay.
Once I've established the spoil board, I still almost always use that only because that gives me a visual check if for some reason my machine got knocked out of alignment.
Yeah.
But if you have your tramming all set up, then you could do it in either direction, whichever you prefer.
Yeah, I use the raster with an offset and a first profile cut. So I get around the whole rim, and then I'm back and forth. I guess my concern was taking an inch and a quarter. I think my spoil board cutter, which is indexable, is an inch and three quarters of diving into the middle and working my way out.
Oh, I see what you're saying. Let me bring up my spoil board bit. We'll take a look at this. So there we go. So yeah, mine's an inch and a quarter as well. I've got it set for a max of 0.02. I rarely cut that deep because generally that's more than I need once I've done my first cuts. Now looking at this, this is a pretty small area, but you were talking using the raster and you profile first, and then if you use a pocket allowance, negative 0.5, that'll hang over the edge a little bit, like that.
Right.
And that's fine. Now, as far as using the, let's go like that. So that's no, there we're saying what the path looks like, left and right, and go around the edge.
Yep.
The other option is the offset, which is, like I said, the reason I use that, try this, I could still put a pocket allowance on this, and I could add a ramp. So for this bit, I might put a 3-inch ramp. And you're correct that it will start out here in the middle someplace. That light blue area right there is the ramping.
Yes.
And so it's going to, let's slow that down. We can probably see that. So there, it's going to go like that, ramping down. Yeah, and I have found, again, the cut is so light that I'm not too concerned about it. But I will admit, occasionally I've had that area look like it's getting a little bit hot because it's staying there in the same place.
Yeah, like I said, that was my thinking in going with the raster initially. Put it back with my
either one's okay. Like I said, the reason I use the offset is because that way, if I'm going to get ridges across the front or the back, I can tell if I'm out of a line that way and this way. If I'm only using the, this is with the offset, if I'm only using the raster, it's only going to show me one direction of my tram, the requirement for tramming.
Right. Yeah, and I see that too. That's a good point. Okay.
And like I said, once you've surfaced your table, depending on how chewed up it gets, I try to maintain my cut depth no more than 0.02 for going through my project. And then if I go back, I can clean it up with 0.02. But it's all going to depend. Every so often I have a bit that goes too deep, and that's the way it is.
Yeah, I use a vacuum table most of the time. So I have a spoil board, but then I put the vacuum table on top of the spoil board, and I leave an onion skin in the bottom of everything. I pull everything 20,000 short, between 15 and 20,000 short of going through. So I never lose my vacuum.
That's good.
It goes down because there definitely is some loss there. And then I just use my bandsaw to bandsaw it off, and almost 99% of what I do, I use a round over bit on my router table to clean up the bottom edge.
That's a good strategy.
Yeah. But I jealously guard the surface of my expensive vacuum table. It's like, I'm not going to touch that.
Yeah, you hit that and yeah, you'll be rebuilding it.
Yeah.
So, all right then, guys. Thanks for coming out tonight, and we'll see you here in about 3 weeks. It looks like.
Thank you, Randy.
Thanks, Randy. Good night.
Thanks, Randy.
Good night, Randy.
Good night.